Alright, what's up guys? In this video we're going to pick up with some calculus here. It's going to be another integration practice video, and this is going to be example number 58. So we need to evaluate the step in the integral from 5 to 5 times the square root of 3. We got the square root of 100 minus x squared dx. So this is clearly a perfect example for a trig substitution. So in this case, it looks like what we have is the square root of a squared minus x squared. And trig substitutions don't have to be under square roots, but most are. And in this case, if I have the square root of a squared minus x squared, then that means that x is going to be equal to a sine theta. So the question now becomes, well, what is a? Well, if a squared is 100, then that must mean that a is 10, because 10 squared is 100. So that means that when we do our trig substitution, we'll have x is equal to 10 sine theta. We now need the derivative of that, so let's get that. So that's going to be 10 cosine theta d theta. So now we go back to our integral. The limits of integration are going to change, much like they do for u substitution, so we'll leave the bounds blank for now. And then we'll have 100 minus, and I don't skip steps in my videos, I always make sure I go through all the steps, because I want everybody to see what I'm doing and how I'm getting my answers. And if I'm skipping steps, then I'm not being very helpful. So this is what you get after you determine what's the appropriate trig substitution. And now we clean everything up. So we're going to clean everything up. So we got 100 minus, well, that's going to be minus 100 sine squared theta, because we're squaring not only the 10 here but also the sine. And so I can write this as the square root of 100 times the square root of negative sine squared theta plus 1. Well, the square root of 100 is 10, and the square root of negative sine squared theta plus 1, I can write that as cosine squared theta. So I'll have 10 times the square root of cosine squared theta. Now the square root of cosine squared theta is cosine theta. So this actually just ends up giving me 10 times this, times cosine theta, excuse me. Now, why is that? Well, again, remember that sine squared theta plus cosine squared theta, remember that's equal to 1. Okay, so if I wanted to solve for cosine squared theta, I would subtract sine squared theta from both sides, which will end up giving me negative sine squared theta, or 1 minus sine squared theta, which is the same thing as negative sine squared theta plus 1. And obviously, using that Pythagorean identity, we would essentially solve for cosine squared theta. So that's the reason why this became the square root of cosine squared theta. Just wanted to point that out just in case you might have missed it. Now, since we've done our simplification, we now go back to our integral here. And what that means is we're going to have a 10 out here, and we're going to have a 10 here. So we'll have two 10s, which we know multiplies to 100. And then we'll have two cosines, which will, when we multiply them, we'll get cosine squared theta. So the integral now becomes 100 times cosine squared theta, and that's integrated with respect to theta. So hopefully with me so far on that. I can factor out 100 because it's a constant. And I'm also going to factor out a 1/2 because we're going to use a trig identity for cosine squared theta. So remember the half angle identity, that cosine squared theta, that's going to be 1 plus cosine of 2 theta all over 2. So I can factor out a 1/2 and just write the inside of the integral as 1 plus cosine of 2 theta d theta. And this is what the integral becomes now. Now I need to change the limits. So since x was equal to 10 sine theta, we need to solve this for theta because we need the range for theta. So that means that theta is equal to sine to the negative first of x over 10. So to change the limits, I plug in 5 for x and 5 times the square root of 3. So we'll go ahead and take that and do that. So we'll get theta is equal to sine to the negative first. We'll stick in a 5. So it'll be 5 over 10 So this would be theta is equal to sine to the negative first of 1/2. So what is sine to the negative first of 1/2? Okay. Well, I know that sine of pi over 6 is 1/2, so that must mean that sine to the negative first of 1/2 is pi over 6. And then we need to substitute in the 5 times the square root of 3 for x. So we'll have theta is equal to sine to the negative first. And we'll have 5 times the square root of 3 all over 10. And we'll need to simplify that. So that'll be theta is equal to sine to the negative first of, well, we can write this as the square root of 3 all over 2. So now what they're asking us is, well, what is sine to the negative first of the square root of 3 all over 2? Well, again, remember that sine of pi over 3 is going to be the square root of 3 all over 2, which means that sine to the negative first of the square root of 3 all over 2 is just going to be pi over 3. So you just kind of have to memorize the ranges for different types of trig functions and whatnot, and you can easily be able to determine what the values are here. Okay, so now we have our new limits of integration, and we're going to use those now. So let's go back to what we had. So we had 100 times 1/2, and then we had the integral. We changed the limits, remember? So now the limits are going to be from pi over 6 to pi over 3. And I'll have, again, 1 plus cosine of 2 theta integrated with respect to theta. Okay? So we'll have 100 times 1/2. And we'll multiply that by whatever we get when we integrate from pi over 6 to pi over 3 for 1 plus cosine of 2 theta d theta. Now, if I integrate, and I'll do it over here, if I integrate from pi over 6 to pi over 3 for 1 d theta, well, that's just going to be pi over 3 minus pi over 6, which is pi over 6. So that means that when I integrate this, I'll get pi over 6. And then when I integrate from pi over 6 to pi over 3, if I integrate cosine of 2 theta with respect to theta, well, recall that that's just going to end up giving me 1/2 sine of 2 theta, and that needs to be evaluated from pi over 6 to pi over 3. Now, when I stick in the pi over 3, I'll have 1/2 times sine of 2 times pi over 3. Okay, and so if we do that, we'll get the square root of 3 all over 4. And if we stick in the pi over 6, well, again, we'll have 1/2 times sine of 2 times pi over 6. So again, we know that 2 over 6 can be reduced down to 1/3. And so in this case, we'll just get minus the square root of 3 all over 4. So essentially, we'd have the square root of 3 all over 4 minus the square root of 3 all over 4, which you know just gives us 0. So if we go back up here, we'll have 100 times 1/2, and this would be multiplied by pi over 6 plus 0. So obviously, this is just going to be 50 times pi over 6 plus 0, which is obviously just going to give me 50 pi over 6, which we know we can reduce down to 25 pi over 3, which would be your answer. So your final answer for this integral here, we're asked to integrate the integral from 5 to 5 times the square root of 3, and it was the square root of 100 minus x squared dx. So the answer here, it's going to be 25 pi all over 3. Okay, that's going to be it. Let me know if you guys got any questions. I'll see you next time.